Hi, this is Maciej Descent, and I have with me Scott. We're going to take you through the process of what it takes to get a Linux solution on an OMAP L138 from Texas Instruments. And we're also going to talk about integrating the DSPLink part with Linux side. So, Scott, we have many customers that want to use the Linux with a DSPLink.
That's right.
Primarily because, well, when you purchase a chip such as L138 that comes with a DSP, you want to definitely take advantage of it, right?
Oh, certainly.
So, what are different components that are involved in getting the complete solution in place such that I can start developing my application?
Okay, well, obviously you're going to need your Linux support, which conveniently you can get from the Timesys factory.
Very conveniently, yes.
And you need some tools from TI for the DSP building, and for the DSP binary and for the DSP-Link package, which will allow you to create applications that use both the ARM processor and the DSP.
Right. Because that's basically how the software is used, right? That
Right.
you run certain software on the ARM side, and you use the DSP as a hardware acceleration or an offload for computations, heavy computations that typically are involved when you do any sort of coding.
That's right.
Yeah. So we have in front of us a website on Linux Link that customers of ours can use to download a set of tools and also get access to Linux software for the ARM side, at least, on the L138. What you're looking at is a typical output page from one of the starting points that we pre-assembled for you, for our customers. And in that output, you can find, of course, binary images that you can run on a reference platform. But one of the output files, and I'm actually pretty bad at selecting just a single file, as you can tell, this one right here called factory.tar.gg is, or that's where, this is our factory tool that we are going to download to a Linux host platform, uncompress, and those factory tools will allow us to not only build a custom Linux platform that includes toolchain, Linux kernel, and the file system, but it also will help us do the integration. And I'm sure that Scott will talk about it in a few minutes. Now, so you mentioned the factory tools to assemble the Linux platform. Open source code is going to be pulled automatically by the factory tools.
That's right.
And the last component that's involved is really a DSP-Link. And that software package can be downloaded directly from the Texas Instruments website. And I'm going to highlight again the URL address. Once you get there, and as you can see, there's a link to always latest code. You will find a number of different files. There's a getting started guide, information on a current release, and as you scroll down, you'll find a number of binaries, executables, and I'll let Scott here identify which files we're going to need for our exercise, but we're not going to definitely download any of those files with you on listening, and we're not going to definitely download all of those files. So how many files are involved typically? 1, 2?
Well, you're going to need the OMAP138 tarball, which has the DSP-Link inside of it, and it has a bunch of other sort of Linux support things that we don't really need, but it is the easiest way to get the DSP-Link software. And then beyond that, you need the BIOS setup tool, the XDC tools, and the code generation tools. I use the Linux versions of them.
And since our desktop tools are Linux-based, we would advise to use the Linux-based DSPLink tools as well.
That's right.
Such that we can provide that added level of integration between the two build systems. So let's step through the process now. I'm going to pass the control completely over to you, Scott, and we're going to do everything from a Linux host that already has all those different components that we just showed you downloaded and installed. But we will show you where those different components are installed, and we will walk you through the process of building those different components. So step one is just simply getting the Linux Mint factory in place. Yeah?
Right.
So what involves getting a factory installed? Can you just briefly show where the factory is installed and how the directory structure looks like and such?
Right, so this is a snapshot of my development environment. So I just have a git checkout of factory, but you would download from the internet and just unpack the tarball into whatever directory you're comfortable with. I like to keep a sort of structured work.
Mm-hmm.
As you can see, I have like a project and then the board I'm working on and the factory for that board. So if you look inside, you see we have a, this is a pre-built example. So I have a build directory already set up, and you can see the different components that are used in the factory. And so after you get that set up, the next things you want to do are to unpack and install the TI tools.
Okay. So you don't have to run first the build of a Linux platform with a factory to just assemble the file system, cross tool chain, and the Linux kernel?
No, you don't need to do that first. You can, but it's just as easy to do everything, do the whole build all at once.
In one step. Excellent. So as you said, after the factory is installed on a local host machine, and by the way, this is, as you can see, a make-based build system. For more information on factory, we advise that you consult one of other recordings that we have that can take you in details through the process of how factory really works and what are different options and choices that you can make. So once the factory is installed, you download the DSPLink components that you just pointed to, right? Where do you store them? What do you have to install them?
Well, by default, they all come with self-extraction installers. So I think by default they all just install to your home directory, which is fine. I did a little different. I have them all sort of contained in an OMAP directory near my project, but you can pretty much put them anywhere.
There's quite a few subdirectories here. So all those subdirectories are created by those 4 download packages that you've mentioned.
That's right. Actually, what I did was I took the OMAP installer that I showed you earlier, and then I unpacked that, and then I installed the BIOS and the Cogen and all that stuff. I just installed all that inside the directory with the other OMAP stuff.
Okay.
Just to keep it all sort of neat. But you can install it anywhere. Really doesn't matter the factory. You can just tell it where you put it, and the factory will be happy with that.
So installation, it looks like it's really a process of decompressing the archives into specific subdirectories, right?
That's right.
There's no modification of different text files anywhere on a host system.
No.
It's just a process of putting the subdirectories at a specific location on your hardware.
That's right. You just need to run the installers for the different components, and then you'll be ready to go.
Okay. Excellent. So what's the next step? We have a factory in place. We have all components for the DSPLink in place. What's next?
So next, you want to go in and configure your factory build. We use, much like the Linux kernel, we use a menu config system.